Warm welcome to all. I am Dr. P. Narayanasamy. I am working as an associate professor in the Department of Mechanical Engineering. Today I would like to explore the topic about tool wear and tool life. Generally, tool failure it implies that the tool has reached a point beyond the lifetime, and tool wear it is tool failure is occur on the basic criterion, 4 criterion. First one is wear, and second one is breakage, and third one is chipping, and last one is deformation. Mainly three modes of failure is occurred: fracture failure and temperature and gradual wear. The gradual wear is the main criterion. The gradual wear, before we talk about the tool wear, we need to know about the mechanism. This is the workpiece and this is the tool, and after the interaction of tool and workpiece, we are able to see the chip. This is the chip upward direction. With the interaction of tool edge and workpiece, we are in this spot, abrasive wear will happen, and with the abrasive particles, there is a minor chip particle. It is stick on the tool or stick on the workpiece further. Then the interaction between the tool and workpiece, it will happen adhesive wear. Adhesive wear will be happen the interaction of tool and workpiece with the small abrasive particles. Then the tool flank portion, we are able to see the diffusion wear, and finally oxidation wear, which is it is happened by the interaction of atmosphere air with the tool and workpiece. Right. Then the preferred mode of tool failure, it is a gradual wear. After seeing the wear mechanism, it is very clear. Fracture and temperature failures are prominent failures. Whether gradual wear is preferred because of longest possible of use of the tool usage of tool. It is classified into two type: crater wear and flank wear. This is the crater wear. Crater wear we can able to see in the tip of the tool, and flank wear, it is the bottom of the tool portion. It is interacted with mainly workpiece. And one more thing, in general crater wear is relatively very small concern, and flank wear, we are able to see the flank wear here, crater wear here. If the cutting force increase significantly with the flank wear. Right. Next, it is a not major wear type. It is one more type is there, corner wear. In the corner of the tool portion, its wear mainly it is happened by while we increasing the tool length, it will happen. Right. These are the combination of all the type of wear in the one single point cutting tool. This is the exact micrographic image of crater wear in the tip, flank wear in the tool surface. Right. These are the factors affecting tool life. First one is tool very foremost factor is tool material, and second one is harness, and third one is workpiece material, and surface roughness of the workpiece also main factor, and profile of cutting tool, and machining operation, types of machining operation. What are all the types of operation? Maybe it's a internal operation or a external operation. For thread cutting, the wear will be more when compared to facing, and cutting parameters like cutting speed and feed and spindle RPM, depth of cut. These are the cutting parameter which affect the tool life, and cutting temperature also. And tool life criteria is denoted by actual cutting to time to failure, and the length of the workpiece, and cutting speed for the given time to failure, and the number of components are produced with the single tool. These are the graphical representation of cutting tool equation with the effect of cutting speed, different cutting speed, and this is a numerical logarithmic plot of cutting speed versus tool life. Here we are able to see the different cutting speed with the tool life. If we increase the cutting speed, cutting speed, the life of the tool is very low. The tool wear is a time dependent process, already we seen. Depending upon the cutting speed, we are able to control the cutting tool life. And this is a relation defined by F.W. Taylor. Vt power n is equal to c, whether V is the cutting speed and T is the tool life, C is the constant, and n, C and n is the constant which is taken from the plot. This is the logarithmic plot between the cutting speed and tool life. This is this table shows the various materials corresponding to the tool life equation and constant and n, numerical value n. For high speed steel and other cemented carbide tool, it depends upon the tool material and cutting speed. And tool near end life, it will changes by sound during the operation. It will be observed by the operator in during working, and increases the motor current by requiring the single cut. Right. Next, this is the wear control plot. Mainly tool wear is happened by cutting temperature. The temperature is raised in between the tool and workpiece, tool material, workpiece material, and contact stresses, and finally cutting tool shape and fluids, cutting condition. By these 3 parameters, we are able to control the tool life. Thank you.